Hello everyone, welcome back to my channel. I'm Swaroop, and in today's video we are going to talk about list comprehension and lambda expression. So what is a list? Well, you can store data inside list and it will be able to hold heterogeneous data type. But in today's video I'm primarily focusing on int. So for that reason I've mentioned over here list within bracket int. That means the list that is numbers will be accepting only integer data. Here I've gone for a while loop and it's infinite. After each input it will ask you if you want to continue the loop, press 1, otherwise we terminate from the loop. Once you have taken the input from the user, we are going to see the list of numbers that you have given, and thereafter we come to the list comprehension. So let me uncomment this segment of code. Okay, so what we have got over here, this is the first example of list comprehension. As you can see over here, since the term list, so we have got a third bracket that represents that it's a list comprehension. How exactly it works? Well, it's a very different way of writing the syntax, and you have to understand it also in a very specific manner. So if you come over here to the statement, you will notice that over here I have got num, but for the time being just ignore num. You read this particular for statement. So what we are doing over here, from numbers, in each iteration we pick up one input and we store it inside num. After that we are performing a kind of decision making. Is that num mod 2 is equal to 0? If that's so, that means it's an even number, right? If it is so, then we will pass that number over here so that we can store it inside another list of type integer that is called even underscore num. Hence this particular list comprehension is primarily going to accept only those numbers which are basically even digits. Okay, and then we are going to see that as an output. Fine. To move this particular concept one step ahead, this list comprehension has got the involvement of else as well. So previously we just have got if, so we don't have any else part involved, but in this case we have got both else along with if, or I can say first if followed by else. So the pattern of writing this syntax is slightly different in comparison to this one. Why is so? Well, over here just imagine we are performing a kind of filtering. Why did I say that? The reason is only those numbers which are even, I will be storing them inside this list. That means this list is not going to hold all the numbers, right? But that's not the case in this scenario. Here what happens, we will be working on each item. Either it will be a positive, or I mean even, or else it's going to be an odd number. So irrespective of whichever type, we are going to store them inside this list which is of type string. So over here the list is going to hold the reference of even or odd for each input, not just for specific one. Like in this case it was just accepting only those which were even, but not in this case, right? So we will be implementing this process in a slight different way, and this you have to keep it in mind. So if you have to start reading right from here, for the time being we'll ignore all those things. Okay, so as I said previously, in each iteration it picks up a single number and it's stored inside num. Once this part is done, I mean for the first number, now we come to this if condition over here. Is that the number divided by 2, I mean modulo 2 is equal to 0? If it is so, in that case it's going to be even, otherwise it's going to be odd. So whichever type it is, thereafter it will be getting stored inside this particular list, which is of type string. So that means if there are 5 numbers, irrespective of being even or odd, all those 5 reference will be over here. But in this case, if there are 5 numbers are there, it will store only those which are even digits, not the odd. So over here we are performing a kind of filtration, but over here we are performing a comparison for each type, and irrespective of the data type, I mean what type of value it hold, that will be stored right over here. So that's the reason why this is slightly different. Okay, so let's run the code and see how exactly these two list comprehensions are working, and then finally we'll come to this part. So here is my program. It is asking me to enter a value. So what I am doing is that I'm giving a value like 1, and if you want to continue, press 1 again. Yes, I want to continue, so I'm going for 2, press 1. I want to go 3, press 1, 4, press 1, and lastly 5, and I don't want to continue further, so I give 0. I hit the enter, and as I said before, that this is the original list that got printed over here. Alright, now here we are going to see only those numbers which are even. Exactly out of 1, 2, 3, 4, 5, we just have these two as even, and that's the reason why I said it's like a filtering. Only it will hold those numbers which actually match this particular criteria. Okay, now come to this list comprehension. You can see over here the first number is 1, that is odd, 2, that is even, 3, that is odd, 4 been even, and 5 been odd. So you can see over here, since we are storing the information of either even or odd for each of this input, that's the reason why we are writing this for statement at the end, and we are giving the if or and else as the at the very beginning. So this slight twist you have to remember in context to list comprehension in regard to if else. Okay, I believe it's clear now, right? So let's come to the third list comprehension, and let me comment the segment and let's focus on this one. Well, this is slightly different. You know what we are doing over here? Here we are involving multiple loop. Let me tell you how exactly it's working. What I want to do is that I will provide a set of numbers, and then I will perform, means I have to come up with those two numbers which jointly will give me an even sum. Yes, firstly, there should not be a same digit. Okay, that means x and y should not be same. So it can be like x is having the value as 1 and y is having a value of 3. Perfect, no problem. And then we'll see x plus 1, x plus y. So 1 plus 3 is 4, and 4 mod 2 is equal to 0. So we will be accepting those two digits, that is 1 and 3, in the form of tuple. So this particular list is going to hold tuple, and inside the tuple there are going to be two type of values, and they are both integer type. That's the reason why I've written this particular statement like this way. Okay, so how exactly is working? Well, again, this is a kind of filtration. We are not going to hold all the inputs, so for that reason the for statement came before if statement. But since we are going to work with a nested for, so for that reason, how exactly is working? Well, you pick up one number from the list and store it in X, and then you come to the inner loop. You pick up maybe the same number, you store it over here, and then you go to the comparison. Well, since in the first occasion both the numbers are going to be same, so it will be discarded. And then the inner loop iterates and pick up the second input, and it comes over here. This time, if they are not same, then we come to the second comparison, and over here we have a logical operator and, so that both the conditions need to be true. In this way, keeping the first number intact, you will be comparing with all other numbers that is there in the list, right? After the comparison get over, then the outer list will be incremented so that it points to the second input, and this process will continue again from the very first till the last. After completion of that, again the X will be having the third number, and this entire process will again continue from 1 to up to the n. That's how the thing is working, and whichever numbers are fulfilling both the condition, we will store them in the form of a tuple, and that tuple will be added inside a list. So let's go and check it out how exactly it's working, right? So over here now I'm going to provide a number like 1, and yes, I want to go with this. 2, I want to go with this. 3, I want to go with this. 4, I want to continue. 5, I want to continue for the last time. 6, and that's it. So here we come. Oh god. So these are the numbers, as you can see over here, are the numbers that jointly will be providing even sum. So 1 plus 3 is 4, even 5 plus 1 is 6, and so on and so forth. 3 plus 5 is 8, and 6 plus 2 is again 8, 6 plus 4 is 10. These are all even sum. That what we have been able to come across, and that was this particular program was referring to. So we saw in this particular list comprehension how exactly we can handle multiple loops, and inside that we can perform some kind of filtration, and for that reason the list will be holding tuple, and inside the tuple we can have the data type in this particular format. Okay, I believe this particular list comprehension was quite different from the usual pattern, isn't it? Great. So we did come across these 3 implementation of list. Now we move to the Lambda expression. So let me clear the screen right over here, and let me uncomment this 3 statement. So Lambda, Lambda always makes me feel surprised. Why? Because we know that Lambda is referring to a function. So this is a single statement function that Lambda come across. Now what was bothering me is that you have seen that whenever I define a data type, I explicitly mention their data types over here, right? I mean, when I declare a variable, I explicitly mention the data type, and I go and very minutely inspect that. I don't just write over here list, but even that list will hold what type of data, that I also mention over here, like the way I did in this case. I mentioned list, at the same time I mentioned inside the list there will be tuples, and not only that, I didn't stop right over there. I even said that that tuple is going to have these 2 format of data. Right, so minute inspection I do in context to variable declaration. Now when it comes to Lambda, I was really unable to figure out that when we declare this variable, I know that this variable is going to hold a reference to a Lambda function, but that what I'm not satisfied with. I wanted to find out what would be the data type of this reference. After doing a bit of research, I did come across something called Callable, but by default Callable will not be implemented by Python. Okay, so we have to give a call to this particular library, that is from typing import Callable, and once you do that, now you have the reference of Callable. Okay, although this is there inside Python, you don't have to install anything, but just you have to mention this particular statement, from typing import Callable. Now after getting this word callable, what made me worried is that why it is called callable. The reason it's been called callable, since this particular reference is going to call someone. So when we are talking about a function, we means that we can call the function. So for that reason the word callable has been referred over here, so that this particular reference can be used for calling someone, isn't it? That's great, right? Now just calling is not enough. Why? Because the Lambda takes parameter, right? So it can take multiple parameters. So for that reason you have to emphasize even that as well. And Lambda function returns, it has a return type as well. In this case, like it's returning string, that too you need to mention. So when you're writing callable, it has got a pair of braces. So these are like outside braces that the callable is going to hold. Inside that, the first parameter you again find over here the list, and this list is holding the data type in form of parameters. So as you can see over here, Lambda is accepting single parameter, that is x, and it is of type int, and that's the reason why I wrote over here int. In case, suppose if Lambda was also accepting another y, which is also a type of int, then I would have written over here comma int, not over here, sorry, comma int right over here I would have written. So in that way this particular callable is going to hold what exact type of parameters you are accepting. Isn't it interesting, right? Yes, it's really great. So Lambda can also accept multiple different type of parameters, like the first one being int, the second one being float. That also you can write over here like int comma float. So the inner list at the 0th index will determine what parameter the callable is accepting. Okay, and what about the second one? Well, this is a return type, and since it's just going to return a specific type, so we will write it separate. We don't have to mention it within a list. So Lambda function, according to this particular segment of code, well, what is happening is that you're giving a call to this particular function right over here, and it is going to pass a list. Okay, let me tell you from the very beginning what is happening. As we saw over here, that we are accepting multiple input from the user, and that's what I want to pass it to my Lambda function. I want to do a filtration over here as well, like what we did at the initial level. So here we were doing the filtration. So this same program, I have converted it into a Lambda expression. So I will pass in each iteration one number at a time. So who will be responsible for doing this iteration? And that brings us to something called map. So map is going to pass each number. Okay, so here is my Lambda function, and here is my list. So map is going to iterate. It will pick up the first number and it will pass it to this particular Lambda expression, and that number will come to x, and that x we are going to check whether it's a positive number. If so, we write positive, otherwise we write negative. So either case will be true, right? So that will get stored inside this particular reference variable, and it's returning a string, as we can see right over here. Now the return value which is going to come over here, since we are giving a call to map, so map is responsible for performing this iteration. By default, the return value will be also a map reference. Now we can't keep it as a map, we have to convert it to list, and for that reason this is going to be a list, and this list is going to hold string data, because either it is positive or else it's negative. So we are not performing any kind of filtration over here, because we are verifying each input, and finally that is what getting stored over here. Either that will be positive or that will be negative. Okay, so let's run the code and see how exactly this Lambda function is working. And here we go. So I take a number. This time I'll go with combination of positive and negative number. Let's start with 1, and it's a positive number. Let's start with 2. It's also a positive number, but this time I'll go for -3. I will continue giving my input, and one last input I will give as -5. Okay, and oh, I was supposed to continue with 1, but I have given it -5. So there's only one negative number, right? So 1 is positive, 2 is positive, -2 is negative, and 4 is positive. Perfectly, this Lambda expression is working. So what important thing did you learn from this is about this callable implementation, right? It's really amazing. I was looking for this for a long span of time. Finally I did come across. Okay, so I believe this made you understand that how exactly Lambda is working over here. Now let's move on to the second Lambda expression, and this time we are going to perform a square. Okay, so here I did not go for any more callable implementation, but I hope you understood. And so what we are doing over here, again the map is coming in picture. It will pick up one number at a time. It will store it, and it will pass this to this particular function, and then we are going to perform the square, and that square we need to refer it back, and again this is going to be of type map, which needs to be converted to a list format, and thereafter we'll store it inside this particular square number, and we'll see the square of each of the input that we have given. Okay, we will run this, and we'll also run the last Lambda expression. Here we find some kind of filtration is taking place. What we are doing, well, we are going to accept again I'm giving a call to this particular reference variable, and it's holding this Lambda expression. We can see that it has a single parameter, and it's checking that whether that parameter is greater than 10 or not. So that means it will return only those numbers which are basically greater than 10. And again the filter will have a reference of type filter, which we need to convert into a list, and then it will be storing the data. So in this particular statement, what we find over here is that we are performing some kind of filtration, because this particular variable, or better to say this particular list, will hold only those numbers that are greater than 10. Rest are just omitted, right? So let's run the code and see how the output of these two Lambda expressions are going to be reflected over here. So the first one is going to hold the square of all the numbers. So I will give a combination of both number which is less than 10 and a number which is greater than 10 for this particular lambda to come in picture. So I start with 1, yes, I go with 2. These are all numbers less than 10. I go for 3. Oh, I'm sorry, my mistake. Let me run the program once again. Let's go with 1. Yes, I want to continue. Let's go to 2. I want to continue. Let's go with 5, and I want to continue, and now I'm giving a value greater than 10, suppose 12. I want to continue. Let me give a value less than 10, again 6, and the last value is going to be suppose 15, and I don't want to continue further. I hit the enter, and as you can see over here, this is the original list which we have given, and it has done exact square. Okay, I didn't give any negative number, otherwise that would have also worked. So 1 square, 2 square, 5 square, 12 square, 6 square, and 15 square. Perfect. So the second lambda expression also worked very successfully. And let's come to the last one. As you can see over here, we did a filtration. We accepted only those numbers greater than 10. Exactly, we have got 12 and we have got 15. These two numbers got stored right inside this particular list. Well, the video was a bit extensive, but I believe after watching this particular video you have really understood how exactly list comprehension and lambda is been implemented in real world, right? So that is all from this today's video, but I would tell you that this particular content which I have shown you, you need to work on this. Okay, so in the next video we'll look at another important feature of Python. So thank you for watching, and I will see you in the next video very soon. Bye bye.